dear viewers. Welcome again to another opportunity to learn with the Chidons Academy. I am Nwachukwu Daniel. This morning we'll be discussing normal probability distribution. This normal probability distribution is another or one of the continuous probability distribution we have. It has a function called probability density function. This function is written mathematically as f of x equals to 1 over standard deviation raised to the power of 2 pi exponential minus 1 over 2 x minus mean all squared all over variance. Now, this normal probability distribution we are seeing, the function has a curve. The curve is called standard normal curve. Look at the standard normal curve. A sketch of it. This standard normal curve has a property. It has many properties, but one of those properties is that the mean is 0 and it is located at the center. And also, the variance, that is the total variance it has, which is the total area under this curve, is said to be 1. So mean equal to 0, variance equals to 1. Now, this normal probability distribution, since it has mean of 0 and variance of 1 for each standard normal curve, it means that the function for the standard normal curve will be, take the value of mean equal to 0 here, take the value of variance equal to 1 here. So see what we will have. F of x for the function for the standard normal curve will be equal to 1 over, when you put, this is standard deviation. Standard deviation will also be 1 since the variance is 1. So 1 over square root of 2 pi, then exponential minus 1 over 2 s minus your mean is 0 all square all over the variance is 1. Just put these values here, knowing that standard deviation is square root of variance, and that is square root of 1. So that will give you that the function for the standard normal curve will be equal to 1 over square root of 2 pi exponential minus x squared all over 2. Now, this normal probability distribution we are discussing have other properties, and one of it is that it is bell-shaped. You can see it is bell-shaped. Another one is that it is symmetrical to y-axis and to the mean. You can see the mean is at the center, which is 0. So it is symmetrical to y-axis and to the mean, which is 0. This mean that is located at the center is also known as the location parameter. And because it is a location parameter, you know that it is located at the center. Now, the variance also, it has a variance, which we say that the variance is 1. The variance means the total area under this curve. And not only that it is the total area under the curve, which is 1, it is also mean that the variance is called the shaping or the spreading parameter. So the variance is known as the shaping or spreading parameter in normal probability distribution. Now, in solving problems on normal probability distribution, you must have your 4-figure table that contains normal probability distribution table. This is mine, as you can see. So we will use it in solving problem in this normal probability distribution table. Now, to solve it, you must know what your z-score is. Your z-score is noted to be x minus mean all over standard deviation. You must know this formula, because before you can locate anything in your table, you must know your z-score. If you don't know your z-score, you will not be able to locate it in your normal table. Now let's see a question. You can see a question. They said that the mean is 100 and the variance is 256. That we should get the probability of x greater than 80. To solve it, we say our x will be equal to 80, so that we can put it in our z-score. We say for x equals to 80, it implies that our z-score will be equal to, so we are converting it to z-score so that we'll be able to locate it in our 4-figure table. Now we now say x minus, x is our 80 minus 100, which is our mean, all over. They gave us variance. Standard deviation is always square root of variance, which is 256, which is equal to 16. So it implies all over 16. And this will give you minus 20 over 16 equals to minus 1.25. You have succeeded in converting it to z-score now. So you can now locate it in your normal distribution table like this. You locate it. Tell them that yes, the center is always 0. That is the mean. That is the location parameter. Then here is negative in our number line, and here is positive in our number line, as we all know. Now, this minus 1.25 is located at the negative side, which is minus 1.25. But the question is, get the probability of x greater than 80. We have converted the 80 to what? Z-score, and we locate it as 1.25. It means that this 80 you are seeing as z, as x, automatically with our spiritual eye in z-score, it is minus 1.25. And because it's minus 1.25, s greater than 80 means look for the region that is greater than 1.25 in this normal curve. Is here greater than 1.25 or here? Is here. And also, we click here. After shading here, it means that everything you are seeing here is greater than 1.25. Now, what is the probability now? The total half you are seeing here is known as 0.5. Now, the total half here is also 0.5. Now, get the probability from 0 to this. Look at this. Probability of z equals to 1.25. While checking it, neglect the negative because you will not see negative in your normal distribution table. Now, you look for 1.25. Now, I'm looking for my own 1.25. It will give you 0.3944. I will write 0.3944. That is 1.2 under 5 in that normal table. Now, since here, which is 0.5 is shaded and the probability of this, that is from 0 to this, is 0. This, it means that probability of x greater than 80 will be equal to 0.5 plus probability of z equals to 1.25. And it will give you 0.5 plus, because here is included, the region from here and here is included. That is why we are adding, plus 0.3944. And that will give you 0.8944. Hope you understood it. Now let's go to the next question that says P, okay? P such that the S is greater than 75 and less than 95. Now, the implication is that, say when S is equal to 75 and also when S is equal to 95, let's get the z-score. The z-score for this will be 75 minus 100 all over 16, and this will be minus 25 over 16. And minus 25 over 16 will be giving you minus 1.5625 if you press your calculator very well. Then for this one, it will give you 95 minus 100, which is the mean, all over 16, and that will be giving you minus 5 all over 16, and that will be minus 0.3125. if you also press your calculator well. Now, we have succeeded in converting it to z-score. Z-score, z-score. So we can now put it in our normal distribution curve. Yes, the mean is 0, this is negative, this is positive. As you can see, you know that this is negative part. Then minus 0.3125 will be located first, minus 0.3125, then minus 1.5625 will be located next. So it means this region bounded by this curve is what we have to determine. Remember that from here to here is the probability for this 1.5625. Then from here to here is probability for this. Now for you to get the total probability that is bounded by this, you say probability for this one that is higher in terms of positive. Probability of z equal to 1.5625 minus probability of z equal to, change this to positive 0.3125. That will surely give you, go to your your normal table and get 1.5 under 6. 1.5 under 6. That will be giving you 0.4406. 0.4406 minus 0.3 under 1. 0.3 under 1. That will be giving you 0.1217. With this, you have solved the question. Then, what matters now? This minus this, you subtract. This minus this, 0.4406 minus 0.1217. This will give you 9, 1, and 3. So when you subtract this 1.56, you cross check to be very sure. 1.56, that will be giving you 0.4406. Then 0.31, that will be giving you 0.1217. Then when you subtract 16 minus this 9, 9 minus this 9, 9 minus this will give you 8. Then 3 minus this 1 and this will give you 3. That will give you 0.3189. We solve the next question. Now, to solve the next question, we also get the z-score. We also get the z-score when s equal to 75 and also when x equal to 124. This will give you that your z-score is 75 minus 100 all over 16. And this will give you minus 25 all over 16 and minus 1.5625. Then for 124 minus 100 all over 16, equal to 24 over 16, equal to 1.5. Locate it in your normal curve. Here is 0, negative 1.5625, and positive 1.5. So this is the region that lies between 75 and this. Then the implication is get probability of 1.5625, then add it to this, probability of from here to here plus probability of from here to here. Add it to probability when R equal, when Z equals to, let's write it well. Probability when z equals to 1, and probability when z equals to 1.5. That will be when z is 1.56, we'll be having 0.4406, 0.4406, plus when it is 1.5, you'll be having 1.5, 0.4332. Then when you add the two, it will be giving you 0.8738. Yes. So we have finished solving the question. Please like the video if you enjoyed the topic, subscribe, and